Hey everyone, today we are talking about LangChain. And no, it's not a new fitness routine. It's actually about making AI useful. So here's something to talk about. How does an AI actually become smart? Imagine a robot that talks really well, but that's literally all it does. It can answer questions, sure, but it can't check the weather, can't remember you, can't use apps. So it's basically just a confident talking parrot. So this is where LangChain steps in. Think of it like a Lego kit for building an AI brain. It connects the model, the brain, with tools, rules, memory, and context. Basically, the glue that turns random pieces into a functioning robot. When you combine all that, you get an AI agent. Kind of like a smart robot child. You ask something, it thinks, decide if it needs help, uses a tool, and then answers. So here it goes. You question, it thinks, it checks if it needs any tool, and then it answers. So it's time to give robot a brain. It can be GPT or any other model. And we tune creativity using temperature. Low temperature, it's a strict teacher mode. Medium, it's a friendly assistant. And high, it's a chaotic storyteller inventing dragons in the forecast. So thus, we give robot a personality because nobody wants a boring robot. Tell it you are a weather expert who's speaking puns. Now, instead of it's sunny, you get it's a wonderful day. So it's much better. We also gave the robot a toolbox. It can be a weather tool, it can be a location tool, whatever it needs. And the cool part, it chooses which tool to use. Like, I don't know the city. Let me find the location first. So that's the decision making. Okay. And next, the context. We give it user info, basically an ID card. Now it knows who it's talking to. And just to clarify, LangChain doesn't magically know your location. It only uses context you provide. From there, it gets your location. And memory. Without memory, every conversation starts from zero. But with memory, it remembers past interactions, which makes it feel way smarter. You can even tell it how to respond funny tone, structured output, clean formatting, basically teaching your robot some communication skills. Finally, so now look what we have built an AI with a brain, tools, rules, memory, identity, and the ability to think before acting. That's the upgraded version. Remember back at the beginning? When we talked about the AI that could talk, the super confident parrot that couldn't actually do anything, well, this is the glow up moment. Without LangChain, that's exactly what you get. Just conversation, no tools, no memory, no decision. With LangChain, now the AI thinks, decides, uses tools, remember context, basically acts like a real assistant. And that's LangChain in a nutshell, a framework that helps you build smarter AI system that behaves more like real assistants. So let's check out some code. So let's build the SQL agent. Okay. So before we go to the agent part, the agentic AI, I would like to see the documentation part. So this slide I explained is basically taken from the LangChain official docs, where you can just check the same example, and it is just explained in a funny way in the slides. So you can just check this document. I will share the link in the description. Okay. Now let's go to the coding part. Okay. So for coding, I have a cloud account in Google Cloud, and there I have created a table. So basically, you can use any SQL for this, like any database for this. So here I am using BigQuery, but apart from BigQuery, you can use MySQL or SQL Server. Now, any SQL, like DB you have, or any other DB you can use. You can use a document-based DB as well. Okay, so basically, I have created an order table here where I have uploaded some data. So this table is containing some data now, and in my code, basically, I like to have an agent. Okay, so my code I will just explain here. Okay, so basically, first thing is that I have used Llama, and then I have shown the same agent in with using Gemini. Okay, so here I'm using Llama. So this is like a the flow of the code. So basically, user puts a question. So with LLM, we understand the context and we generate a query, and that query is then uses a tool that is kind of like a tool which helps to run this query in your database, and it fetches the results. And again, with the LLM, we just beautify that result and give the answer. So this is a context of how this is how a SQL agent to be built. This is the flow. Okay, so next you will have to install all the necessary libraries. So these are the libraries which you need to install. And I have an environment file also, so .env file, which you can just define over here. You can just see these are .env file where you can just define your basically the DB IDs. So this is my project ID in Google. This is the project ID, and this is my dataset name, and this is the table name. So these are some of the things which I am taking from the Google Cloud. And apart from that, you can put the API key here. So you can keep the API key here, since I am already having the cloud account and I am using the Gemini API from there, and Llama is open source. So I haven't mentioned any key over here, but definitely if you are using GPT or any other language model, you can use that API. Okay, so let's go to the code. And it's a very simple code. So I have basically loaded all the environment variables here. And first thing I will check that whether my Llama is up and running. So Llama, for using Llama, you can go to Olama official website. So if you just search Olama, so it actually opens olama.com. So you can just go to Olama, and here you can search for Llama. So if you want to use Llama, or if you want to use any other tool like Mistral, like language model, sorry, you can use. So if you want to use any other language model, you can use. So if I do type Mistral, so it comes here. So here I'm using Llama. So I will just go Llama, put Llama here. And I'm using Llama 3.2 and this one, 3B model. So this one I have downloaded. So if you just go here, you can just download Llama 3.2 in your system. And to run Llama 3.2, you just have to put Olama run Llama 3.2. So this is a command you have to put in the CLI. So that will actually run the Llama server. So that this command will run Llama here. And once Llama is running, so Llama uses this port 11434. So you can just check whether it is running. Just copy this localhost link and you can put here and you can check that. Okay, so if you find this message, Olama is running, that means your Llama is up and running. Okay, so let's go back to the code. So my Llama is running now, and I have invoked a small message over here, hi, and it is giving me a reply also, how can I assist you or help you today? Okay, so that's fine. So now I have to connect to the Google BigQuery. So I'm just using all the environment variables. And now the first thing, so I'm giving the agent a brain, like as I explained in my slide. So here I'm actually giving that brain. So I am calling the Llama model here, and Llama is running in this port. So Llama is getting called from here. Now I'm creating the tool. So what are the tools in this case? The tool is, the first one will be generating a SQL query from the natural language, or from the query which is coming from the user. So from that, the first tool will be generating the SQL query, which will be running in the BigQuery dataset. And the next one will be running that query in the BigQuery dataset. So we have two tools here, and I will define it as a tool only. So here I'm just putting two functions here. So first one is, because Llama is a very, it is a small language model. So basically, if we use these functions as a tool, it doesn't give proper response. So I have tried multiple times, but it's the same thing I will show you in Gemini, how I have converted these as a tool. And I have bind those tools in the LLM. So with Gemini, it works fine, but with Llama, so it gives some problems. So that's the reason I am just using two functions here. So one is generate SQL, and I'm giving a prompt here. Basically, this prompt is very simple. And you just don't worry about this code, because this code link is in my GitHub. So I will be putting that link in the description box. So here I'm just giving a prompt, and I'm just putting the structure of my table. So how my table looks like, all the column names. And I am just putting that whatever query comes, you just return the SQL query, basically. So here I am invoking the LLM, and I'm getting that SQL. So this SQL little bit comes in a, because, it's a very small model. And it is also like running in my local system, basically. So it comes not always very, correctly, like some kind of, little bit cleanup we have to do. So this is a cleanup of the SQL query, which I'm doing here. So some date format sometimes comes wrong. And so some cleanup I'm doing over here. Okay. And then the next function is that running this query in the BigQuery dataset. So that is what it is doing. So basically it is connecting with the cloud, and it is just running this query. Okay, so now all set. So I am giving in two formats. One is in data frame format, and another is in a JSON format. So both the formats will be coming here. So once I call these tools. So here actually I have created an agent. So kind of not an agent, a function basically, which will run the query. So here I'm defining here actually basically I am telling that run this query, and I'm sending a query over here to this function. So I'm calling basically these two functions, run query df, okay, and run query JSON. So this one. Okay, so these two functions I'm calling here, and which will return me the query in it will actually create the query, run the query, and fetch me the result in a data frame format or in a JSON format. Okay, so now to test it, I am just calling this function run query, and I am passing like a question, like I just want to see the cities with the highest number of orders. So I'm passing this question to this run query, and this is a response. So it is generating the SQL first. So it is giving me the SQL, okay, and then it is running the query and fetching me the result. The same thing it is doing in the JSON also. So it is generating the SQL, it is just running the query and fetching me the JSON output. So you can test with the other queries, which is relevant to your data set, and check how it works. So this is how it works with Llama. And with Gemini also, it will be, like a little bit more advanced, because Gemini is a big model. And so the same thing, like some necessary libraries I have installed here. Only instead of Llama, the LangChain Llama framework, Llama library, I am installing LangChain Google Gen AI library here. So these are some of the necessary installs here. And the same way I have imported my environment variables, and the same way I have connected to the LLM. So I have given a brain to the agent. So which is here, the model is Gemini 3 Flash Preview. So it is a brain to the agent. And then here, a little bit difference is, if you see in the last code, where I have used Llama, there I have used just normal functions, and I haven't used any tools as such. But here I am defining tool here. So the same function I am defining as a tool. So my first tool is generate SQL, which is taking a same kind of like prompt, and which is invoking the LLM and giving me a SQL response here, and which is finally I am putting it in the clean SQL function, and I'm cleaning it a bit. Okay, so this is the first tool. And the second tool is run BigQuery. So here I have created a tool which is running the SQL which I found from which I got from obtained from Generate SQL tool, and that it is running on my Google dataset. So basically BigQuery dataset, and it is fetching me the record in JSON. Okay, so I have just created two tools here. Now I'm creating an agent here. So here, this is a standard thing. So basically standard syntax. So I'm creating an agent where I'm telling these are my tools. I have given a brain, and I have also bind the tools with the brain. Now I'm giving a prompt to the bot that you are a data analyst AI agent. First call generate SQL. So I'm telling that first call this tool, then call this run BigQuery tool. Never answer without tool. So you don't go to answer without this tool. So first you use these tools and generate your answer. Who is a user? User is a human, and human is giving an input. Okay. And this is a kind of a normal syntax, like you have to keep a placeholder where it keeps basically the conversation. Okay. And now I'm creating the create tool calling agent. So this is a function. Basically, this is a function in the LangChain framework. And I'm using LLM with tools, and I'm providing it tools, I'm providing it prompt, and then I'm executing this agent. So basically, I'm returning this agent. So this create agent function is creating an agent with everything, with a brain, with tools, as I have explained in the slide, and it is returning me the agent. Now I'm running this agent. So once I run this agent, so this is a function for running the agent. So you can see that I'm just creating getting an agent from this create agent function. So it is returning me an agent. So I'm just getting that agent, and I'm invoking that agent here with my query. And this query is coming from here. This query is something which I will provide as a user. Okay. So now I am calling this function run agent, and I'm passing this query. Okay, the same query. So it is with the highest number of orders. And here you go. So it is invoking first the generate SQL tool, and with this question, and then it is giving me all the necessary, giving me the exact SQL I want to run on the BigQuery dataset. And then it is running it also on the BigQuery dataset, and it is fetching me the results and giving me the final answer.